Hey guys, welcome to the Pre-algebra 8.6 video where today we are talking about writing linear equations. Alright, so the first thing let's talk about is just taking kind of a sentence and constructing an equation. So there's a line. It has a slope of 3 and a y-intercept of 2. We're going to write that equation in slope-intercept form. Okay, so slope-intercept form, what does that mean? Well, it means y equals mx plus b. And we know that y equals and the x are going to stay. But we just are going to replace m and b. Well, what is m? M is our slope. They tell us, though, the slope is 3. So my slope's 3. Plus my b. Okay, well, what's b? Again, that's our y-intercept. And they say it has a y-intercept of 2. So I do plus 2. And guess what? I'm done. All right, so what would the equation of the line that has a slope of negative 7 over 2 and a y-intercept of 9 be? Well, again, we're looking at y equals mx plus b format. And the y is going to stay, the equal is going to stay, the x is going to stay. So what's m and what's b? M is our slope. They tell us the slope is negative 7 over 2, so it's negative 7 over 2 times x. Plus our b. Well, plus, what's our b? It's negative 9. So how would I rewrite plus negative 9? Just a lot better to write minus 9. And again, we're done. That easy. All right, so how about this, okay? So we're going to do the same thing here. We want to write the equation of the line. However, they don't tell us the slope or the y-intercept. They just give us a graphed line. Well, we can find the slope, and we can find the y-intercept very easily. So remember the slope, I'm going to look to find 2 points that are on that line. Okay, so I'm looking right there and right there. All right, those 2 points are definitely on the line. Well, what's the slope there between those two? Well, to go from here to here, I would rise negative 1 and then run positive 2. So the slope is negative 1 over 2, or negative a half. Now what's b? Well, again, b is the y-intercept, okay? So this is our y-axis. Where does this line hit the y-axis? Well, it hits right there at positive 1. So we are looking to put this in slope-intercept form, so it's going to be y equals the slope times x. Our slope is negative 1/2 times x, and then plus our y-intercept, which is 1. And we're done. All right, so same thing here. What is the equation of this line? Why don't you pause the video, just see if you can get it, and play it when you're done. All right, so it's going to be in y equals mx plus b format. We're still in slope-intercept form. What's my slope? Well, if I'm going to identify a couple points here, I'm seeing this point and that point, okay? So what's the slope between those two? Well, it would be down 1, right 2, so the slope is negative 1/2. And then what's the y-intercept? Well, it's hitting the y-axis right there between 1 and 2, so I would call it 1.5 or 1 or 3 over 2 or 1.5. Of course, we don't really like to say 1.5, so we could say 3 over 2 instead. So 1.5 or 3 over 2. So you could write it a couple ways. Y equals negative 1/2 x plus 1.5, or y equals negative 1/2 x plus 3 over 2. Either way would work. All right, so next we're going to mix it up just a little bit. And so what we're going to do here is we're going to write the equation of a line, okay? But it's the equation of the line that's parallel to y equals negative 2x minus 3, but this new line passes through the point 0, 2, okay? So it's parallel to this line, but the new line has to pass through that point, and then we're going to graph it. So let's remember back to 8.5. What do we remember about equations that are lines that are parallel? They have what kind of slope? Well, they have the same slope, right? Parallel lines have the same slope. Okay, so if the slope of the original line is negative 2, well, what do you think the slope of our new line is going to be? Well, it's going to be negative 2. So we're going to have y equals negative 2 times x, but then we got to figure out, well, what's the y-intercept here? Right? What's the y equals mx plus b part? Well, it can be negative 3, obviously, because then it would not be a line parallel to this. It would be the same line. Let's think about this point, 0, 2. If I were to graph 0, 2, where would it be? Well, I would start at the origin, go left to right 2, and then, or left to right 0, and then up or down positive 2. So I have a point right there. Well, look where that point is. That point is on the y-axis. So when we graph this line, it's going to have to pass through this point. And what else do we know? Well, we know that the slope is going to be negative 2. So I'm going to start at this point, and I'm going to graph the next point using the slope of negative 2. So down 2 to the right 1, could do that a couple more times. Or I could go back here, and instead of -2 over +1, I can do up 2 over -1. Okay, so up 2 and then left 1. And vice versa, and again. So there you go. We have it. All we have to do next is connect it with a line, because we're supposed to graph it. And that's pretty close. Not bad. And there you go. This line is y equals -2x, and then what's our y-intercept? +2. Okay. Now if we graph this original one, the y-intercept of that one is -3. And the slope is -2. Okay, so down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. And of course, we could do the same thing there. Oh, that was like almost perfect. I didn't hardly have to adjust that at all. That's pretty fun. Okay, and there you go. We can tell when we graph them, we can check to see if we did it right, because these are indeed looking quite parallel. All right, so I'm going to have you guys try this one on your own. Pause the video and then play it when you're done. Alright, so just similar to the last one, we're going to graph the line that is parallel to this line, but it passes through the point 0, -5, okay? So this line has a slope of 1/2. Well, we know that parallel lines have the same slope. So our new equation, I'll do this one in red, is going to be y equals, well, the slope on the first line was 1/2, so this one's also going to be 1/2. But what's the y-intercept? Well, let's think about this point. This new line passes through 0, -5. So if I graph that point, it'd be right there. And that point is on the y-axis, so that point must be our y-intercept, and it's -5. Okay, the y-coordinate of that point is -5. And so then if we graph this, I'm going to start at my -5, which again came from there, and then I'm going to rise 1, run 2, or rise -1, run -2, because remember that 1 over 2 is the same as -1 over -2. Why? Because a positive divided by a positive is a positive, and a negative divided by a negative is also a positive. So this is basically the unsimplified version of this. And we can do one more, and then of course we connect them with a straight line, and we're done. Except for arrows, of course. Alright, so let's apply some of this. So this table here shows you the growth of an empress tree, which is one of the 35 fastest growing trees in the world. And the table shows you the growth of that tree that you planted in your yard last year. So if you look at the table, we have time since being planted in your yard in months, and then we have the height of the tree. And this is going to represent our x, and this is going to represent our y. Okay, and so what we're going to do first is we're just going to graph this data. We're going to see if there's a trend, and then we're going to see if we can find an equation for that trend. Okay. So let's graph these points that we have here, 0, 8. And before I do that, I ought to look, okay, 0, 8, if each one of these goes by, if each one of these goes by 1s, then I'll be able to do 0, 8, over 0, up 8. But I'm going to have to go over 6 and all the way up to 14 at some point, and there are not 14 vertical boxes. So I'm going to change the scale a little bit. Now, before I actually change it, let's label it. Because this is our x, then if x is this row, then our x-axis is going to be representing the same thing. So up here, this row is time since being planted. So I'm just going to shorten it a little bit down here and do time. And then for our y, well, it's height. So what's our y-axis going to represent? Also height. Okay, so height and time. And let's see, again, I'm going to have to graph 6, 14. If I try and graph that this way, I'm going to have to go over 6 and then up 14, which would be way off. So I can go over 6 just fine. It's going up 14. So let's change the y scale to go by 2s. So instead of each of these representing 1, they're going to be 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. We can stop there. Okay. Now, these are all going to stay the same. They're actually going to each represent 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's totally okay to do. You can change the y-axis but not change the x. Or I could change the x-axis but not change the y. Totally okay. All right, so let's graph these values. 0, 8, so over 0 up to 8. Okay, that represents the height of the tree 0 months since being planted. So that would be the day you planted it. And how tall was it? 8 feet. Now 210 over 4, then up 12. And then lastly over 6 up to 14. And there you have it. There is our data graphed, okay? So let's look at our table, make sure it all matches up. Yes, it does. So what we're going to do now is let's figure out what's the equation that's represented here, okay? And the way I need to do that is first make sure, okay, is there a consistent pattern of change? Well, what if I went from this point to this point? Well, I'd go from 8 to 10, so that's up 2, a rise of 2, and then I would run from 1 to 2, I'm 0 to 1 and then 1 to 2. So I'm running 2. So actually 2 over 2 is 1 over 1, or just 1. So my slope is 1. Now that looks kind of weird because you're like, well, aren't you going up 1 and then right 2? Shouldn't your slope be a half? Well, you got to count using your scale. I'm going from 8 to 10 here, so I'm actually going up 2 and then from 1 to all the way to 2, from 0 all the way to 2, so that's another 2. So that's how we got 2 over 2. Okay, from here to here, well, that's up 2 and then right 2. Up from 12 to 14, it's up 2 and then right 2 again. So we know that we actually have a slope here if we were to connect these in with connect them with a line. So let's go ahead and do that really quickly. I'm going to put a line in here. Let's see if I can get it to, I'm going to just move this line to match up. It's not bad. Okay, now I'm going to put an arrow here, but I'm not going to put an arrow down here. Why? Well, because time is going to continue on, right? This tree is in your yard and you're going to leave it there. Okay, so we only have enough data for the 6th month, which we said at the 6th month it's 14 feet tall. But using this model, we could predict how tall it would be on the 8th month, the 9th month, the 10th, so on and so forth. However, I don't put an arrow here because how could I know the tree at -1 month since it's been in my yard? That doesn't really make any sense because this table is only for the height of the tree since it's been planted in your yard. It's not for the height before. So you bought it at a nursery and it was how tall? Well, it'd be 8 feet tall because 0 months since you bought it, it was 8 feet tall. All right. So we have enough information to tell us the slope. We said the slope was 2 over 2 or 1 over 1. So the equation here would be y equals 1x. And you don't even need the 1 because you could just write x. But then what's our y-intercept? Do we have one? Well, if we look here, our line, or our ray, which really this is because it has one endpoint and one arrow, it's a ray, it hits the y-axis where? Well, right there at 8. So we actually know that our y-intercept is 8, positive 8. And there you go. That is the equation that models the growth of this tree, the height of the tree, as a function of the time since it's been in your yard or the number of months it's been planted for. All right, so next we're going to talk about the line of best fit, okay? Now, there are very, very, very specific ways to calculate the line of best fit. We can use our calculator to do that. But before we get there, I really just want to make sure we're good with understanding what it is, okay? So the line of best fit is used to figure out a trend when you've got a lot of data and that data doesn't all exactly line up. Okay, so for example, I graphed all these just kind of semi-random points in here, all right? But we can tell they kind of trend downwards, right? There's no point over here, there's none over here, there's none down here, or way up here. They all kind of fall in this general line. So what we're going to do is we're going to try and figure out what the line of best fit is. So, you know, roughly you could come and you could just kind of sketch that in and say, well, it's like roughly right there. Okay, it looks like that line kind of splits all the data in half. And that is kind of true. You know, for all intents and purposes, that would work for us for right now. So I have another one over here that I kind of pre-made up. But what we want to do is I'm going to try and get a line that I can actually calculate the slope for. So I put that line in there, and I'm going to see, okay, does this like fall, or does this run through the y-intercept anywhere? Well, yeah, it runs through right there, which to me is looking like positive 2. So if I'm calculating my slope and my y-intercept, well, my y-intercept looks to be 2. Now, are there any other points that this line goes through? Well, yeah, I mean, an infinite number of points, but it's looking like some obvious ones are like maybe right there, and maybe right there, and right there. Okay, so now I'm going to calculate my slope. Well, to go from here to here, I would go down 2 and then right 3. So that looks like a negative 2 over 3. And then the same thing would be if I went from here to here. down to right 3. Or if I went from here to here, I'd go up 2, but then left 3. So we would say that negative 2 over 3 is our slope. So the equation of the line of best fit here is y equals negative 2 over 3x plus 2. Okay, and there you go. That's the line of best fit. All right, y'all. That's all I got for you. Thanks for sticking with it. Look forward to seeing you in class, talking more about slope, parallel, perpendicular lines, and line of best fit.